So I hopefully I'm not out of place here. I took this as an challenge to present application of an LLM, which is, I think, not exceedingly novel, but still many people don't know about it. And I didn't look into details what other how other people approach this. I know they did. So we'll be talking about steerable computer vision pipeline, which means LLM basically instructing, not with the code, but with, let's say, declarative kind of a language, what to do to solve our problem, okay? So I'm Yanis Perš from Faculty of Electrical Engineering. I work in the HPC area for about 3 or 4 years. Otherwise, I'm expert for computer vision. Not that much for LLMs, but I use them a lot. Oh, basically, what do we have in computer vision? We have basic situations where we need to, when we need to quickly give out a prototype. This is in industrial projects, in projects then when the questions come, you know, when you need to make a quick offer, there is a huge pressure that you provide the quote within, I don't know, a month or 2 weeks or something like this, and you have to quickly check whether what you're thinking you will doing is even possible, okay? And here it is the idea, how do we trade a massive amount of computing power on a HPC, and we save on engineers, okay? And so people that would actually need to study the problem. So basically, we use large foundation models. We then connect them, and the sequence is of course fixed, but we make our LLM to actually set them up, to set the parameters, to set the queries and so on. And then it drafts the simple text, which then it's read by computing pipeline. And this computing pipeline execute these models on an HPC with the strong GPUs, with a lot of computing power and so on. So now, what are the foundation models? These are, let's say, holy grail, okay? Foundation models are very large pre-trained AI models, and every big AI company who wants to be like in the game has at least one. So these foundation models, like GPT's foundation model, okay? So then we have a lot of models in vision. Foundation means that they do on any task, like segmentation of image in patches for any task, whether you put in the situation of the production lines or you put in basically photo of the street. And there are a lot of tasks that you can do, and I will describe these later. So the idea of these models is that learn broad visual concepts. They know everything. So let's say they eaten everything in the world what is there to learn, yeah, about their particular task, about segmenting, about detecting object, anything. Now, this means they can be reused for any task. Like you suddenly get some idea, you get a question from someone, hey, can you do this application? But you don't need to train them, yeah? So they're like general. The problem is they're very expensive to run, so they are fit for HPC or GPU nodes. All right, this is work very nicely, but still, they may use like 10 seconds, 20 seconds, 50 seconds per image, just to do some very basic thing that otherwise we could do it in optimized way in let's say different specialized model. Now, why they would help us to actually build working vision systems fast and check if the problem is solvable. Yeah, and you will see the other role is I talk about the other solution later. So one of the foundation models that we use, the first one is SAM2. Maybe you know it, segment anything from Facebook. So it actually proposes high quality binary mask across the image. Now I don't have image here because I was struggling with the HPC node for about 2 hours now to get these images, but I can show the examples later if we have time. So basically, it separates image to a different object, but it does not tell us what the object is. Yeah, so it can work on anything. So then, the next model is CLIP. I think this is from OpenAI. And this is basically zero-shot classifier. So what does it mean? Basically, you ask him, it classifies the image patches with regarding to the strings, or you can make it. So it calculates the distance between the string goat is grazing. I have goats that I developed these things for because it's so exotic stuff. I couldn't have any pre-trained model. So goat is grazing, and then the actual image of the goat that is grazing. This is high-level stuff. It has been pre-trained again the whole world, and it gives you, for example, the cosine distance between this description and this patch. And you go through all the patches got from SAM2, and you can classify those which contain, I don't know, goat or something, spaceship or whatever, yeah? So then this turns usually up with a lot of, let's say, decent number of false positives. And then the third thing that we do is, of course, we need a model that we ask basically and query him for a binary answer. Is there an animal here? So give him the patch. The patch said, okay, this is the goat, yeah, nothing else. And you say, okay, is there an animal here? And then he says, no. Then we throw it away. It was a false positive. Now, everything here is not 100%. It's a 90% if you're lucky, something like that. But the problem is that you need to program this each time anew. And this is, well, complicated task, right? So if you want to do every time. So what did we do? We actually put together that kind of a system where we have these all blocks here, these foundation models. Of course, we load them on a GPU. I test them with H100 or V100, and now I wanted to do it on an NVIDIA A100. But the idea is that we have images or video, doesn't matter. Then we do some basic pre-processing, so something fixed. Yeah, we cut out the small place, like the region of interest. And then we run this SAM2. Then we do some filtering, very fixed filtering, no deep learning involved, like largest, smallest object that we expect. This is something that can be specified to very few parameters. Then we clip, yeah. So then we calculate the distances between our, let's say, objects we want to see, and then we do the verification. Now, this looks a bit complicated, but now we come to this steering via YAML, and I will first show the example. So this is a text that is generated by an LLM, and it has to be multimodal LLM. When we put in the, let's say, when we put in the image or few images, yeah, like I use ChatGPT for this, the thinking mode, and the sample, how this YAML should look like. And then it analyzes the images, and then what it does actually fills up these things. Now, this pre-processing is usually checked manually, it's not a problem. But then, for example, mask generator, this is SAM2, yeah? So, and it gives you some basically based on the image, gives you some parameters. This also are not that difficult. They can be also set manually if you're not very good idea, okay? Then some processing about the maximum size, but then we come to the thing then where, and basically provides a number of labels that fit that exact image. Okay, so in our case, where I think I can basically show the images, so you will see what is. Okay, just a second. So, yeah. Okay, we'll show it later. So you know, it can see there are pictures of literally goat that I got for people who research farming at the Farming Institute of Slovenia, and or let's say it could be here. These are the images now. And then actually it looks all representation and put in something like this. It's going to be very long. And then for blip, you know, it's basically just a question: is there animal in the image? Now, of course, without searching animal, they would the LLM would put something else. You know, if we put train, it would put, I don't know. Or we would put cars. Yeah, is there a vehicle or something like that? Not original prompt. For verification, and then there is something, you know, how do you set the results? How do you want to see the results? Okay, so this is this part that is also not that very complicated. Now, when we have this YAML file, this you can see this is very simple format. So LLMs can master it. It's not that difficult. The key is that they use their multimodal abilities to actually see what is in the image and provide these hints. And what we can do then, sorry, well, the beginning here, which I went over. So basically, what I showed you now means we have pre-processing, very easy generation of masks. So where are the object, but we don't know what object. Filtering, just some very similar, very easy rules, human-made. You know, then labeling. This is the problem. You know that LLM shines. Verification. Two questions, you know, which can ask: is this to verification, and then output. Yeah. And we can run this a couple of times, iterate, tell the LLM, look, you didn't do it right. I'm getting tons of, I don't know, grass patches on the field where I told you to only search for goats, and then it will reiterate it. So it's a quite fast iteration. Now, when we do this, we can take advantage of the multiprocessing. So once we have things done and we have 1,000 images to process, we can use the whole everything that is on HPC. So quickly from 1,000 images, we get in 1 hour maybe annotations or 1,000. And what is this good for is actually distillation. So, you know, many production settings don't want HPC.
Jairus, we cannot see your slide.
Again.
Can you try again, please?
Yes. Okay. So sharing is not turned on again. Somebody has to allow to me. Somebody clicked something.
Let me see if I can do something. Can you try now, please?
Yeah, now I can. Obviously,
okay.
Yeah. Thank you.
Sorry.
Tell me as soon as it goes away. So what is then the obvious benefit of this setup? You know, in computer vision, many production settings want small models. Yeah, like YOLO here is the one. This is object detection, very popular. Don't need to go into details, which need the labels to be labeled. Okay, and our task was, for example, that we get from people from the Farming Institute of Slovenia. We want to detect all the goats and build the statistics where they are, where they're grazing. So if you look at the images, you cannot just go and you can go and scrap the whole web of images, but they had special kind of goats. So it wouldn't have sense for them to use months of scraping the internet and then manually annotating, because they had the data set. They have 10,000 images. Yeah. So what we did, we basically run it through this pipeline. We got the results, which were about 90% correct. Of course, we took 1,000 images, we processed around 1,000 images. Then we remove all the images that had problems, and let's say we had 900. But those 900 were good, but we didn't annotate by hand. Now, we use this pipeline to export not the positions of the animals, but basically to actually write a data set. Yeah. So this was here in the end, so for example, export YOLO, where basically we wanted to detect things. This is the sign that showed where is what kind of the grass and the goats. Yeah. So and split and so on. So this pipeline with the proper code, which it was written. It's not that the LLM would do. I mean, not in this context. Would then export the data set, and voila, in a couple of hours or in a day, you have like 1,000 training images and like 5,000 cases of annotating objects. And now, why would you use it? Yeah. So rapid prototyping, batch curation. If you have, of domain image, you have things in the domain. You don't have something scraped of the internet. Literally, somebody comes to you and said, "I have this problem. This problem is limited, but I have a ton of images. I don't have anybody to annotate them." Yeah. So, of course, it has to be moderate complexity, not something that the foundation models would break their teeth on. Yeah. And you can basically make quite quickly the training set. Now, if you need real-time budget without installation, this wouldn't go. This is very slow. Let's say 1 minute per image, maybe 30 seconds, 20 seconds per image on the H100, I think, yeah. And if you have very fine-grained categories, this is, of course, a problem. Yeah, you cannot have like 10 different models of the cars. This won't work. It's good if you have goats versus a bucket and versus, I don't know, a sign. Yeah. And of course, if you have privacy constraints, you cannot use public LLM to use it for configuration. So at least some images have to go out into LLM if you want to do it. So now I will end out with the takeaway. So we have idea where we use actually the LLM as a domain expert, which configures our very rich foundation model pipeline, which runs very slowly in each HPC. We get the results out. Yeah, these results by themselves may be what we want, but if not, we can use it to actually train smaller models with this. So, and this would be it. Thank you. I can show something. I don't know now with all this mess here, how much time did I spend? Maybe I can show just the images and the on which I ran the stuff. So just a second.
Yeah, if you have images,
yeah.
Can I ask something though while you're trying to do that? The data annotation and so on. Do you have maybe some sort of an estimate how much time you saved from following your approach compared to doing it by hand, for example?
Yeah, very easily, because we used to do these things by hand. And we ended it like 3 years ago, but this would be, let's say, for that kind of the data set that was processed in 1 hour, it would be like 1 week person, or maybe 2 weeks, okay? So something like that. and this was, and the HPC processes said, now, of course, you need to iterate the prompting, yeah, because first result wouldn't be okay. Sorry, I'm just here. So first one wouldn't be okay, and then you would go to better one, and so let's see, goats. Okay, thank you. I have here the data. Okay, so do I share still?
Yes, we can still see your,
Okay,
your
so
screen.
this is I did it for other stuff which I can show the results. I have some results for this too. So for example, this is the case. This is what people came to me and said, okay, we want to detect these goats. You can see they're all, they could tell me they're all of the Boer variety. There is nothing else than grass, and you have this fence and so, and these signs. Okay, so then I can go and show you some results here too for some other cases that I tried to. So, okay, experimental data that we have. Okay, I think I have soccer tomato. No, okay. Project zone. Yeah, okay. I won't be able to find them so far. So if you have any question, you're free to ask. Maybe while answering, I can maybe see where they have. Or let me see this. I can download them directly from the HPC where I have some old remnants of this code.
Are there any questions for Yanis? Okay.
No? Okay. Yeah.
Thank you, Yanis.